Alright everybody, welcome back to another video. In this lesson we're going to be discussing state machines and how to really amplify our game logic and how to better organize our game logic. So if you want to follow along with this part, you can come to my website, visit the projects section and this Godot for Golang MMO, and just scroll down to lesson 4. And if you want to download the code so far, you can come over to this link here and just download the part for the end of lesson 3. But if you've been following along so far, then let's get started. So first things first, I'm going to open up VS Code, and we're just going to jump into setting up a state machine on the server side. And you might be wondering, what is a state machine? Well, it's basically just a way of separating our logic for our game into different states. So one state might be for logging in, and all of the logging in logic is going to occur in one file. And so we only need to worry about listening for very particular kinds of packets in the login state, and then you can transition between the different states. So once a particular thing happens, there will be some logic built into the login state to then go ahead and transition into the game state. And similarly, there might be some different states for browsing a high scoreboard, for instance, and stuff of that nature. So setting up a state machine is just really good practice for separating the different concerns of logic. And we'll be doing that on the Godot side of things as well, and I'll teach you how to do that. So let's go ahead and define what a state is in our hub.go file. So under server, and then internal, and then server, we have hub.go. And let's go ahead and sketch out an interface for what we want in a state handler. We're going to call it a client state handler. We're going to make this an interface so that we can define many different kinds of these as long as they implement the methods that we define here. So every state handler is going to need a name, which is just going to return a string. And this is just a method for using dependency injection. So we're going to, every time we create a state handler, we need to tell it what the client that owns it is going to be. So we're going to have a set client method, and we're just going to give it a client interfacer. We're going to have a method that gets called onEntry. So every time you transition to this state, this method, whatever code is inside, is going to get called. And we're also going to have a handle message method. So this is just how do we define all of the different packets that we're receiving. Each state can handle messages differently depending on the context. And finally, we're just going to have an onExit method, which is kind of the opposite of the onEnter method. So this will just be cleaning up any resources that we've created during the lifetime of this state. So now we're going to need to provide a way to switch to a particular state from a client interfacer. So let's go ahead and modify our client interfacer interface to include a new method called setState. I'll go ahead and put that here. We'll give it a parameter called newState, which is going to be an instance of our client state handler. So now that we've defined the interface, let's go ahead and implement one. We can go ahead and create a new folder in the server folder. So server, internal server, create a new one inside that nested server folder called states. And we're going to go ahead and create our first state, and it's going to be called connected. So go ahead and call it connected.go. So first things first, we can go ahead and say that this file belongs to a package called states. And before we start implementing all of these methods, we first need to define the struct that is going to hold all of the information that this state is going to need. So we're just going to need a very simple struct. All it's going to do is contain a reference to the client interfacer, and we're just going to call that client for short. And as I type this, it's going to start importing the things that I need for me. And we're also just going to have a custom logger. And we can use the name of this state as a prefix for the custom logger. So now our goal is to implement each of the methods that we laid out in the hub.go file in the interface. So we need to implement these 5 methods. Starting with the name. That's a pretty simple one. We're just going to go with returning the simple string of connected. The set client method is going to also be pretty simple. We're just going to set our state's client property to the supplied client. And let's go ahead and also set a logging prefix. So logging prefix equals, do a formatted string. We'll call it client placeholder. And then in the square brackets is going to be the name of the state. And we're filling that in with the client ID for here, and then the state's name here. So this will say like client 1 connected. So as we have more states in the game, it'll be pretty useful to have the name of the state that they're in printed in the square brackets. So now we can actually set the logging prefix on our logger property. And this is pretty simple. We've already seen this line of code before in the Websocket.go. This is basically just the same line of code. Alright, we've only got 3 methods left. In order to preserve the functionality that we already have over in our Websockets.go, we were sending an ID packet on the initialize method. So instead of doing that, we're actually going to be using our state to handle that. So when we set the state to the connected state, that's when we're going to go ahead and send a new ID packet. So let's put that inside the onEnter method. We're going to do c.client.socket send packets.newID c.client.id. And we just need to import our packets, which should happen automatically when we press Ctrl S, or you can just type server/pkg/packets at the top in this import block here. So that's our onEnter method, already got some functionality in there happening. And the last 2 methods I'm just going to leave as empty. Alright. So now we have errors in the websocket.go file. We're going to go ahead and refactor a few things in there. So first of all, we are going to need a reference to our current state inside of our WebSocket client struct. So let's put that in somewhere, maybe before the logger. Doesn't really matter. So we're going to call it state, and it's going to be a server.clientState handler. Now we obviously need to implement the setState method that we added to our client interfacer interface in the hub.go file at the beginning of the video. So let's do that now. I'm just going to put it maybe down here. And all we really need to do is update our state to the supplied one. But if we want to add a little bit of logging and call the onEnter and onExit methods of the new state and the old state respectively, we'd better go ahead and add some more logic. So we're going to go and say previous state name is none, just before we know what it is. And then we can just check to see if the previous state is not nil. We can go ahead and set the previous state name to that state's name. And then we're also going to call that state's onExit method. Now we're going to try to find the new state's name. And if the new state is not nil, so you can actually supply a nil parameter into this method, and it will essentially be used to shut down the old state. Go ahead and say new state name equals the supplied state's name. And then we're going to go ahead and log switching from state, old state to new state. Set the actual state now. And then we'll just check again to see if the new state is not null. We're going to go ahead and inject our client into it and then call the onEnter method. We can save that setState method on our WebSocket client, and all of the errors should disappear from this file now because we've satisfied the interface from hub.go. So let's come back to the initialize method. And as I mentioned before, instead of doing the logic in this method, we are going to be simply setting the state to the connected state so that that will go ahead and call the onEnter method, and that will go ahead and send the new client ID to our client. So all we need to do is call c.setState, and then we'll pass in a new state, a new connected state. And we don't need to supply any properties to this struct. We can just go ahead and press Control S there, and that will automatically import the server states package. So we should actually be able to go ahead and restart the server, and we should have a working chat room like we did at the last part. So if I press F5 now, we shouldn't have actually lost any functionality. I'm going to go ahead and open the Godot editor. Open up the project. You can see we don't have any errors on the server so far. It says awaiting client registration. So let's run the game. And we see connecting to server, and we received our client ID just as we did in the last video. So we're back to where we started, except now every time we want to create new functionality, we can go ahead and create a new state inside the states folder, and we can easily switch between the states with the new client interfacer method setState, and all of the cleanup and entry code will occur for us. The only thing that's not quite ideal is we are still performing some logic in Websocket.go. So in the process message method of the Websocket.go, we don't actually want to be performing any of this specific state kind of logic. What we'll do instead is extract this functionality. We're going to paste it in our connected.go's handle message method. And we'll just update these references here. So instead of c.getID, we need to do c.client.id, c.client.broadcast, and c.client.socketSendAs. And then back into the websocket.go, we need to say, instead of what we had before, we're just going to say c.state.handleMessage. So we're just offloading this processing to our state. So if we change states, this method will be different, maybe performing different logic. And inside the close method of our websocket.go, we're also just going to set the state to nil. And that will go ahead and automatically call the onExit method of our state. If I restart the server, we should still be able to get the same functionality with the chat messages being processed, not by the client itself, but by the state that we are in. So you can still chat to each other, same as before, but now the logic is occurring inside our state. So that's all good and well, but what about the client side? It would be really cool if we could also break our different areas of logic into separate scenes and separate scripts on the Godot side of things. So for that, we're going to need to define something called a game manager, and that's just going to take care of setting states for us and also keeping track of some of the things that we need globally, such as a client ID. So I'm going to go ahead and create a new script just in this res folder called game manager, gamemanager.gd, and it's just going to extend the node, regular node. I'm going to go ahead and open up that script. So this is going to be a global script. We're going to register it as a singleton autoload. So let's come back up to project settings, globals, and we're just going to register our game manager. And we're just going to call it game manager. That's fine. We'll just close this. So that just makes it so that we can refer to our game manager from any other script in the future when we want to be setting scenes and stuff like that. So we're going to go ahead and define an enum called state. And this is going to contain two states at the moment. Entered and in-game. These are our two states. And we're going to register each of these states with a particular scene. And these scenes aren't going to exist yet, but they will when we create them in the next step. So let's lay out a states scenes dictionary. And if you're using Godot 4.4 or above, you can actually go ahead and type your dictionary using square brackets and say that it's going to take states as keys and strings as values. Although if you are using Godot 4.3 or below, you will get an error here saying that only arrays can specify collection element types. if you see that error, you can always just upgrade to Godot 4.4. If you do want to stay on Godot 4.3 for whatever reason, you will have to just get rid of this. And there are certain things that I'm going to be typing in the rest of this series, which you might get an error message about not being able to infer the type from the dictionary. And in that case, you'll just have to modify your code slightly. But I definitely recommend installing Godot 4.4 or above so that you can follow along and get the benefits of having typed dictionaries, which is, in my opinion, a very good feature. So we're going to go ahead and say that the state.entered is going to correspond to res states entered / entered.tscn, which is going to be a path to a scene that we're going to create in a minute. And let's also say state.ingame. It's going to correspond to InGame / ingame.tscn that we're going to create as well. Our game manager is also going to need to keep track of our client ID, so let's put that in here. It's going to be an integer, and it's also going to need the current scene root, which is just going to be a node. And now we can just set the function set state, and it's going to take in a supplied state. If current scene root is not equal to null, then we're just going to delete it. So this is just going to get rid of the existing scene when we set a new one. And then we're just going to load the new scene. So we're using the supplied state enum to go ahead and grab the path to the scene from our state scenes dictionary. And I called this scene states instead of states scenes. And then we're just going to instantiate this scene and set it to the current scene's root. And then we're just going to add it to the scene tree. And by the way, the entered state is going to be the initial state of the game, which is going to be responsible for connecting to the server and listening to a client ID. And then once it receives a client ID, it will then transition to the in-game state, which is then going to handle our chat room logic. So now we just need to actually create these scenes for these states. So let's create a new folder called states. And then inside the states folder, we're going to add one called entered and one called in-game. Inside the entered folder, we're going to create entered scene and just make sure that it's a node. And we'll also create the in-game scene. Let's attach a script to our entered.tscn. So you double click on entered.tscn. You should see the entered root node up here. Attach a script to that root node. Leave the path as default. It should be in the entered folder. And as I mentioned, we're going to define the logic for connecting to the server inside this state. So let's grab a reference to our packets. And let's also have a log inside this scene. So come to the 2D scene view here. And we're just going to add a canvas layer child node. So this will just make it easy to make sure all of our UI stuff is positioned correctly. And we'll rename this to just UI. Capital U, capital I. We'll add our log as a child to the UI node. And then we can just come up here to the presets for the anchor control node, and then just set this to the full rect anchor. So the log will take up the whole screen. And then this is where we're going to have things like connecting to server, connected to server, and all of that kind of stuff is going to get logged to this log node as we are transitioning between states. So we'll come back to the script, and we're just going to grab a reference to our new log node. So onReady var log equals, and you can just click and drag this here. You can also click and drag and then hold control. So hold down control before you drop it in, and then that will type the onReady var part for you. Except I just want this to be a private member, so I'm just going to put an underscore before the log name. I'm going to go ahead and call our ready method. So this is obviously the function that gets called when the node becomes ready. We're just going to do a bit of a transplant from our main.gd script. So we're going to connect. Honestly, we're probably just going to go ahead and copy and paste most of this. Yeah, we're just going to copy pretty much everything except for the stuff that's handling a chat message or handling the line edit. So we'll copy, and then we're going to paste it into our entered.gd script. And let's just remove the line edit specific stuff. We'll just go ahead and fix up that typo there, and all of the errors should go away, except we don't have a handle chat message. We don't need to be handling that here, so we'll just get rid of it. And we're just going to change the functionality slightly. So we're still going to be connecting to the server using our WebSocket singleton. When we connect to the server, we'll still be logging and all of that. We're also going to be listening for an ID packet. The only thing that we're going to be doing differently is we're going to be setting the game manager's client ID equal to the received ID. So we can just type game manager dot client ID equals ID message dot get ID. And then we're actually going to set the state. So game manager dot set state. And then we're going to access the game manager's states enum. And then we're going to choose the in-game state. So this is basically just a copy and paste of what we had in our main.gd file, except now when we receive an ID message, we're going to use the game manager to set the client ID, and then we're going to use the game manager to set the state to the in-game state, which we can create now. So go ahead and in ingame.tscn, we can, I'm just going to slightly rename this to have a capital G, but I don't think it actually matters. It's just mostly for aesthetics. And attach a script to your in-game state called ingame.gd, all lowercase. And this is where we're going to be doing the chat logic. So we're also going to be coming to the 2D scene and adding a UI node as well, so a canvas layer, which we're also going to rename to UI. And then we're just going to have a line edit. And we're just going to set that to top wide. Just so it takes up the top part of the screen like that. And we're also going to add a log node. And let's set the anchor preset for the log node to be bottom wide. And then we can actually set the under layout in the inspector while we have the log node selected. Come to the inspector, layout, custom minimum size, and we'll set the custom minimum height to be 300 pixels. So the log will just take out sort of like the bottom half of the screen. And save that. Come into the script view. And then our in-game script is going to, again, have a reference to our packets. And I'm just going to use the drag, hold control, release trick to get references to our line edit and our log. And I'm just going to make these private so that we don't get, just so it doesn't clutter up the IntelliSense when we're using the script from the outside. But we shouldn't be using the script from the outside anyways. It's just good practice. I'm going to define our ready function. So this gets called when we first transition to the state. And we're just going to connect. We don't need to connect the WebSocket's connected signal. We don't need to connect this signal because that's done in entered.gd, but we will still go ahead and connect the connection closed signal to a handler just in case the connection gets closed while we're in the game. We'll probably just want to log it or something like that. We can just copy and paste the handler from our entered.gd Just put that down here. Just use that our handler for the connection closed signal. And similarly, we're going to steal the onPacketReceived method from the entered script. And we'll just put that down here. Let's clear this because we're going to be wanting to listen. We're going to be wanting to listen to different kinds of packets, but we will connect the packet received signal to that handler. And I just sort of messed up the syntax here, but we want to call the connect method on these signals. So ws.packetReceived.connect, and then the handler goes in the arguments here. And finally, we're going to connect the line edit text submitted signal, which we already had done here in the main.gd script. So I'm just going to copy this. And I'm going to copy the handler for it as well. I'm just going to copy these three things into the in-game script. So we have a handler for when you press enter on the line edit, which is going to construct a chat message and send it off. We also just ported over the handler for when you receive a chat message, and we just need to listen for a chat message in the packet received. We're just going to steal that from main.gd as well. Just this little case here where it's if packet.hasChat. I'm just going to paste that into the onPacketReceived method. So we can save that. And we've transplanted everything from our old main.gd script, so we can delete all of this. And all we really need to do is in the ready method, just set the initial state. So GameManager.setState, GameManager.state.entered. That will go ahead and start doing this script here, which is going to go ahead and connect to the server and then do all of these things, listen for an ID packet, and then transition to the in-game state, which is then going to be calling this script, which is listening for chat packets and also submitting chat packets using the line edit. So we still have our server running from before. We can go ahead and reconnect to it by running the game. And I've just got a small error here saying that we can't call instantiate on a null value. So apparently scene is null, even though we should have supplied it. So let's go ahead and add a breakpoint to this ready function in the main.gd script, because we're calling set state. Oh, I bet I've got like a typo or something. Okay, let's go ahead and rerun the game and let's see. So we should break on this, and we're just going to press this button to step into. So that's going to step into the set state method. See here, so we should expect this to be null, that's right. Let's step over this if statement. This is where we're going to go ahead and grab the scene. So we should be loading the state is 0, which corresponds to entered. That's correct. States scenes 0 is res/states/entered/entered.tscn, which looks good to me. Seems to match what we have here. So let's step over. So it appears to be not nil. We try to instantiate it. Doesn't seem like we got an error. Let's go ahead and press continue here. Oh, okay, so it's actually... Oh, yes. Okay, so it's actually tripping up when we try to transition to the in-game state, because I have a typo here. So I'm just missing an S. So scene was null because it couldn't load, it couldn't find it in the dictionary. Alright. So let's go ahead and rerun the game now. Still going to break on this, but we can just remove this breakpoint because we're pretty certain we fixed the bug. And there we have it. We are in the game state. If by the looks of things. So I don't know why this has 2 and this one has none. Leave all scenes. Stop. Try running that again. Okay, so now they both have 2. Oh, I think I see what's happening. We still have a line edit in our main scene. So if we come over to the main scene, click the 2D view, let's just go ahead. Let's just remove the log, so we don't need that anymore. And we'll remove the line edit as well. They weren't doing anything anyway. They were just sort of getting in the way. Cool, so we've restored the functionality that we had. But now the difference is that we have states going on. So whenever you're looking at implementing logic into your game now, you shouldn't have to worry about any of these scripts. The only things you need to worry about is the ingame.gd or the entered.gd. So this really narrows into the list of things that you need to worry about. All of the groundwork that we've been doing in the first 3 parts and in this part as well has all been just getting everything to be as easy as possible for you in the future when you're coding logic for your game. So we have a really good separation of concerns, not only on the server side, but also on the client side with different states. So I hope that was useful to you, and please stay tuned for the next part where we're actually going to be adding a database to our game and setting up player accounts so that you can register for an account and then log in. And as always, if you are having trouble or if you just want to chat to like-minded game devs following along with this course, please consider joining the Discord channel. But apart from that, I'll see you in the next video and hope you have a great day.